got a here HR21 hybrid machine, and the faults are with the controller possibly, or the customer says master controller, but I think it's to do with the pump controller. They said the machine stopped working and they could start diesel engine to bring the machine down. So the machine's operating on diesel engine, but the machine's being used indoors a lot, so they're mainly using the batteries. So we'll try to have a look at it. I haven't started yet, just to see what's going on, and we will see what error codes we're getting, or what's happening, and then we're gonna go from there. So isolator is out at the moment. Let's switch the machine on. The stop is out. PLC is flashing green, that's good. We got a symbol, the motor symbol here, and the X with the circle, meaning there is error codes present. So there is the error codes 01, F1 and 147. So without checking, I know this is going to be the motor controller error, and 147 is this motor controller specific error. So we can have a look on the flash code on the controller. That should be flashing something. Engine canopy. So here we have a controller, and it does flash the error code. So let's try to read it out. So 1, 2. Okay, so that's error code 12. Let me check quickly what that error 12 code is. I think it's either a pre-charged fault or overcurrent, one of those two. So error code 12. Yeah, controller overcurrent. So it says external short or phases. Or motor parameter mistuned, so that's unlikely. So it's possibly the short circuit on one of those phases. So I would be suspecting the controller. So let's try to do some checks on it and see if we can detect any short circuit. The first thing, I will disconnect all the phases from the controller, so then we can do some resistance checks, and I will show you how to test the controller if there is a phase fault. So you can be sure if you have the error code, because I know that sometimes you may have the error code, but you're not 100% sure if that is the problem. But we will look into it, and we'll show you if that's the case. I will show you how to be 100% sure that is a problem with the controller. Okay, so all wires disconnected from the controller. So the motor is disconnected, so we can access the phase without any side effects from the motor itself. So I'm going to set a multimeter to diode mode. So on my multimeter, the diode mode is that's the capacity, and then the yellow I go into diode mode. The positive of the multimeter goes on to negative, so that's a B minus, and negative we're going to put on the phase, and that should read kind of a diode drop, yeah, so 0.4. So this one is good. So you see, this is something wrong with this phase. It's climbing up. So that's a phase V, and U, it's alright because we're getting the diode drop right away, yeah? Same. So W and V will be fine. It's something happening with this phase here. And then if we go negative onto the positive here, so the black cable on the positive on the B plus, and we can do the same test with the positive going in a phase. So we have the same diode drop and the short circuit here. Okay, so now you know that this phase V is actually shorted into the positive. It's completely short circuit, and the phase U is correct. So if you're not too sure, do this check, and then now you can be 100% sure that is the controller faulty. Okay, just looking for the wiring to see why would that fail, and the cables here seems to run, but all right, let me continue with the investigation and we'll let you know. So those cables are looking good. I checked the relays here, connection seems to be okay. This one is looking good. I found a blown fuse here. Visually it doesn't look like it's really gone. Oh, actually now with the camera I can see it right on the line there. Okay, so it's definitely gone. So I'm gonna go and check the fuses on the other side, the ground fuses, see how they do over there. So here, as always, we have a ground fuses on the bottom here where the blue wires are, and in this case we have a 2 amp fuses. That one is good, and the low one I think is gonna be good as well, or it looks good as well. Yeah, okay, so those ground fuses are good here. But the one on the controller failed. That could lead into failing controller if it was a shutdown through the canvas. If the canvas errors happen, then maybe the system just shut down. If the controller was under load, then maybe it could result in a blown phase. Just to remove the pump, I wanted to see if there is nothing wrong inside the motor. Sometimes you can see you can find some washers dropped in or nuts dropped in through the vents, but it's all looking good. I don't think there is any problems with the motor. So I'm going to replace the controller now. I'm going to put a new one on, and then we're going to test it together, see what's going to happen. The new controller is fitted on now, so I'll do again the phase test as we did before. Okay, I just want to show you the difference. So positive goes into negative, B minus. The black cable from multimeter on the phase, 465, that's a diode drop. Phase V, 465 as well. No delays in the reading, it's straight away, 465, all of them reading the same. And then if you swap over, we go on the positive and the negative, and then positive on the phase, same, 466, 466, 467. Okay, so now we can say this controller has a good phases, no problems with the phases, no short circuit on the MOSFET board, and but obviously that's what you would expect with the new controller, right? But that's the difference, that's the test you can do. Just wanted to check the connections here, because sometimes you can see the contact points are not being in the center, then kind of pushed out, because these are the areas that makes a contact with the pin on the controller, and sometimes they open too wide and they're not making good connection, like this one. You see one here, so it's quite wide, it's nearly open completely, and it wouldn't make a good connection here. So what I normally do, see if I can do it here like this, I try to push them those flaps in, yeah, so you can, I don't know if they're called flaps, but this is this part here, so I try to bend them in a bit so it makes a good connection. So we just want to make sure that there's no issues there, but most of them it looks alright. So that was yeah, that's the one that is not that great, but yeah, I'm gonna go through all of them. It's just something else I wanted to show you that I do. Right, so got the new controller in place, so let's try it out now and see what's gonna happen. So machine started up, I heard the controller click and errors disappeared, so most likely it is working. Let me check quickly here. Status light, yeah, no errors here. So now obviously just curious what's happening here, so I'm just gonna try to move the wires about as is on now, see if we can get a contactor to drop out. The contactor is pulled in now. Yeah, so I'm just gonna go around moving the wires just to make sure there's nothing loose here. It's not gonna trigger anything. Not gonna make it to drop out, and then we're gonna test it with the higher current, run the motor, move the functions. Okay, so I tried moving all the wires around. Everything seems to be working just perfect. I'm gonna try to run the motor now. So let's see if it's spinning. It does spin. Can we get to engine, the motor info? So temperature is okay, speed is good. That's a base speed. Yeah. Okay, seems okay. I will test this more. We'll try to see what could happen. I'm gonna run all different functions just to see if I can get this to fail and if it can trigger any problems here. But at the moment seems okay. Everything is working fine. No error frames in the canvas, so looking good. So the machine is working fine, no problems here. So before I leave, I thought I'm gonna check everything is inside well. So everything is nice and tight and no problems. Inside the chassis, all the connectors are good. So seems like, yeah, it's just a controller failed for some reason, not sure why, but that's what's happened. So I'm gonna test it a bit more, but it looks like it's gonna be good to go. That's the last plug I checked, and look, I removed the cap here, and look what's inside this cap. Is full of water, and this plug is not looking great as well. It does have a canvas connections on it. It's not used, but the other end of this connector is connected, and it does have some marks of corrosion or something. So I don't know. That potentially could be a problem, and that could be causing the controller to shut down unexpectedly. So if that generates a canvas error or jams the canvas communication, the machine just would shut down. And if the motor is running under heavy loads, then maybe it would affect the motor controller as well. Just remove the wedge lock to see what's inside, and look what's going on there. It's really bad. So I think I'm gonna have to remove each pin and just clean it up, dry it up, the connector, or just cut and isolate those wires. I'm not sure. I need to think what's the best way, but it's not looking great at the moment. So I cleaned this up, cleaned all the crimps, dried them up, and then just reassemble. It's just obviously the rain is starting and getting heavier, so it's not helping. What that should prevent the water, and I'm gonna cable tie it downwards direction, so if there is any water, it's gonna drip out. But that was actually, I think, the root cause of all the problems here. So it's interesting how that was the last plug to check. Yeah, so that was very interesting find. So and that was the last actually thing I checked, and it was interesting to see so much water in it, and I think it helps us to diagnose root cause of the problems here. On the track unit I was looking, and I can see on a tracking system that there is a canvas errors, and that plug actually explains why we had the canvas errors and where they're coming from. So I cleaned it up now, and we'll test the machine on. I haven't tried it yet, so let's switch on together and see what's gonna happen. Let me see if I can give you some better view. So isolator is out, key switch. Oh, comms error. Oh, that's not good. I wonder what's happened now. So the ground fuse here is good. I wonder what's happened. I'm just curious actually if there could be something to do with that plug, and if moving the plug has damaged something on the canvas side. Because we have a comms error, the controller is not even starting, the PLC is flashing green. Let me try to disconnect the tilt sensor, because the machine is elevated now and is alarming, so that could be a tilt sensor. Let's try that. So disconnect the sensor here. So right there we have a tilt sensor. Remove the plug. Let's see if it's gonna start up now. Power on. No, same, comms error. Ooh, not good. So disconnected battery management. Still comes error. Alright, so something bad happened here. I don't know what at the moment, but I think the campus line has been broken down on the PLC or on some controller. So I don't have any parts with me at the moment to try it out, and it's a bit getting bad with the rain, so we'll have to come back with some more parts and see what's going on. But I'm pretty sure it was related to the campus side now. The campus is crashed on and then nothing is turning on. And on that adapter, I think I had the 48 volts on it, because I lost a feed on F2 now as well. So it's another day, another $1. So I'm back on this 21 again with the whole motor controller fault and all the campus faults from the last week. So came back with the loads of the different parts. I'm gonna try to look into see what's happened here, why we got the campus faults essentially. So I will try again. I'm gonna start the machine up, and I think we're gonna start it fresh and we're gonna try to understand what's happening. Don't remember exactly where we left or what I found last time, but it's just gonna be continuity of the video. So it's gonna be part 1 was a controller fault and the part 2 is gonna be the campus issues here now we're having. Okay, so let's hope it's gonna be easy fix for us, but at least the day is nice and friendly today. As you can see, the airplanes are flying around right behind me and the sun is out, so it's really cool. So it's better than rain. So just a refresher, the isolator is out, switching machine on, see what's gonna happen. Okay, so it's comms error, PLC flashing green. Okay, nothing is working. I know we tried to do tilt switch, battery management, that didn't work. So I think I'm gonna try to bring the cage down. I'm hoping the PLC inputs or the PLC campus side is survived, but not too sure, because I know the display is getting no message from the PLC. That's why it's showing comms error. Maybe as a trial I can jump in onto PLC straight away, but before I do that, let's do the campus resistance test so we know the termination is good and 60 ohms. Okay, so the base control box is open, so I'll do the CAN check on these 2 wires, the CAN high, CAN low, and it's a multimeter in resistance mode. So we're gonna go, let me try to get into the terminals here. Oh, can't do it in one hand. Yep. So that is all the way in, and I have minus 13 ohms. So don't know how that can be. What do you think that is? Okay, I think what that is, actually, we have a voltage present on the campus line. So I switch the multimeter to millivolts. AC now, let's switch to DC. So millivolt DC, we don't have a great amount of voltage here, so it's strange why we cannot do resistance check. Normally is a voltage presence that is disturbing resistance reading, but in this case it doesn't look like, but the reading is really strange. If I switch to millivolts AC, then we have a bit something here, so you got like 34. millivolts. So I'll try to disconnect the battery management, because normally the battery management that puts the voltage from here, but it would be around 1 volt, so it would be a bit higher. But let's try. So here inside the chassis, by the dry valve, we have this 2-pin gray plug, and that's where the battery management is, and that's connector. I disconnect that connector, so there is no data coming from the battery management into the CAN bus system now. So let's repeat the resistance test without the battery management, and CAN high, CAN low. All right, so we have actually 5 ohms. Oh wow, so that is like a shorted CAN bus line. Okay. Voltage. So we have a 0 volts now. That's good. All right, so we have no voltage, but we have a short circuit. Well, it's not complete short, but it's 5 ohms. It's very low resistance. That kind of explains why Acuity was not putting in 1 volt as you would expect. So now the question, what is doing that? Should we try, I guess, onto PLC? How was that like, huh? Look, I disconnect the PLC plug and the resistance gone up where it should be. Oh, that means PLC has gone. So I'm not disconnecting ST side connector, yeah? So look again. Unplug. 60 ohms, and that's what we would expect. So it definitely needs a new PLC. Wait, let me try to connect the battery management back on, because I want to show you the voltage being here in a normal condition. So battery management plugged back in, and you see now I'm in a voltage DC mode, and I have nearly 1 volt. It's a 0.96, and then if I go resistance mode, it cannot do resistance. Yeah, it's showing some garbage here, because the multimeter cannot measure resistance where the voltage is present. Okay, so that was interesting actually to see how the PLC is shorted on a CAN. But okay, so I know what I need to do. I'm gonna change that PLC, and hopefully it's gonna work right away and nothing else is damaged. Just in process of removing this PLC now. And if you wonder what's the easy access to the screws, this is most amazing Protanium high torque steel. That's actually really cool tool. I use that a lot with the cage consoles, and now I found it's actually very handy here with the PLC, because it fits in through the hole, and it makes the life easier. Made in USA, 3mm. Here we are. That's not advertising actually. I'm not affiliate for that brand or anything. It's just a handy tool to have. So new PLCs is on, and let's try now together if it's gonna work. Okay, so it's better now, so you can see. Hopefully you can see on display we have no CAN bus errors. PLC is flashing green. We have a tilt symbol here and X, so that means error code is present. 01C3. I wonder what's the 01C3 is actually. The one that just flashed. It's interesting that it's flashing, like comes and goes. Let's have a look. Where's my error code lookup? So error code 01CF0000. Okay, so 01CF, that's saying there is inclination sensor error, so that's possibly failed as well. And the flashing 01C3, so C30000 cage node. All right, so maybe there is a problem with the cage node as well. Okay, we're gonna look into that. So let's have a look on the tilt sensor first. Actually, let's see if the motor is running. Yeah, the motor is running, so the motor controller is working. Let me get the links up. Here under the link section there is a tilt sensor, so I'll try to disconnect this one and plug a new one to test, because we have a very specific error saying that that sensor is not working. So I think it's actually that, but before I do undo the bolts here, so I'm just gonna plug it in and just see if the error disappears. So a new sensor here, loosely. Ready? So I think that should fix the tilt sensor error. And it did. It did fix that. Okay, that's perfect. So if you go to where do we go to? Sensor calibration. Now we can read the machine position and angles. Okay, that's cool. Okay, so let's see if we still have that flashing error. Related to cage node. Seems like that disappeared as well. Let's see if you have a functions from the cage, because if that is a problem with the cage node, then we wouldn't have certain functions. So just in case, do the switch test. I'm gonna check the switches here. So look, on the display you have option to see the cage inputs. Green button, so just pressing green button. It's working. Recovery button. It's working. Foot pedal. That's working. Emergency stop. That's working. Where is it going? We go down. Engine glow. So engine switch here. That's a glow. Engine start. That's good. Cage rotate left. Here. Cage rotate right. It's good. Horn. That's working. So all they seem to be working fine. I don't think there is any problems here. Let's do the pedal positions. So all centered. I go up on a jib, down, tele out, tele in, slew left, slew right, primary up, primary down, secondary up, secondary down. Yeah, they all working fine. Actual drive joystick position, drive forward, drive reverse, all good. Steer left, steer right, trigger. Okay, so everything's working here fine. So I don't think there is any other issues here. So what I'm gonna try to do now, just to test the machine out more and see how it's performing and how it's working, and if it's okay, then I think it's gonna be all good to go here. I test the machine for a while now, driving, boom functions, all working fine. And yeah, that was an interesting one. So I started with the faulty controller. So then we found a rusty connector in the chassis, and that was causing canvas issue. And then I think when I disturbed the connector, that's where I introduced the canvas fault on the machine, which damaged the PLC and damaged the inclination sensor. I think that plug is actually having 48 volts on it, permanent 48 volts from the isolator, because it blew up the fuse in the chassis and I lost a feed to the track unit. So potentially, if you have something to do with that plug, just be careful, because there's a voltage there, and it can ruin your day a bit, like it was here last week. It's just a bit better today because the sun is shining and it's easier to work, but it's all fixed now. So as always, thank you for watching. Don't forget to like and subscribe, and I'll see you on the next one.